Alright folks, welcome back to another adventure in the garage. For those of you that are new to the channel, my name is Luke. Today I'm here to help you out with all of the test settings of the ANENG SZ301. This video is geared towards beginners or enthusiasts. I'm going to be going ahead and going through all the settings and giving you my opinions. I have gotten comments in the past, although I do have affiliates with meter companies, and I have been sent meters by mail. Most of the meters I do on this channel, I buy with my own money, and I just give you my honest opinion. If it's not a good meter, I try to let you know to help you all avoid it. If I think it's a great meter, I'll let you know as well. I try to let you know the pros and the cons and everything in between, just so that you're better informed about your meter purchasing decisions. So with that being said, I've done an ANENG meter on the channel before. The one I did before, a lot of people had reported in that there was manufacturing defects right out of the box. I even had to help someone overseas map out their capacitors because they had a couple bad ones in there. So there was issues right out of the box. With this one, I'm going to point out some of the flaws right out of the box that I've noticed. I haven't gone through the wheel and tested all the settings yet. I'll do that together here with you. The first is, it is advertised as a backlit multimeter. That means that this back screen here should illuminate if you hold this hold button, and we get nothing. So that was the first one. And then this is a first for the channel that I thought was really exciting, also extremely confusing, and you might be confused by it too. And that is the capital M, as in Mike, listed here on the meter. That should be a lowercase m for milli. This is also the first meter I've had on the channel that has a manually ranging capacitance measurement function, which I thought was exciting. So the way that this scaling works here is it's going to be 20 nanofarads, 200, then 20 microfarads, 200 microfarads, and then it should be 2 millifarads, as in lowercase m, and it's capital, which in the rest of the meter you're going to see stands for mega. So if it was as printed, that would mean 2 megafarads, which is an incredible amount of capacitance, something you're never going to measure. It's supposed to be a lowercase m, and then you can see here, as annotated on the meter, it's 4 place marks of microfarads. So you would see, if you saw 1000, that would be 1 millifarad or 1,000 microfarads. So I hope that kind of helps clear up some of the confusion. I will say, all in all, this meter does have its flaws and a couple things out of the box that aren't right. However, it is priced accordingly. It's only like a $9 or $10 meter. And I think for that price range, you get a lot of bang for your buck. I've reviewed quite a few meters on the channel that are sold primarily at auto stores that are sold for $30+ that have the same amount of functions and same amount of build quality, and it's just been really disappointing. So with all that being said, let's go ahead and hop into the functionality of this, and we're going to go into the capacitance first and do some test measurements there just to show you. One thing I do really like about this meter is there's no glare on the display when I have it down here on my table and I have my work light. Unlike, not to pick on Fluke, I love Fluke, but you can see the enormous amount of glare I have on the display. With this one, you don't have that. It reminds me of like an old Casio watch. So let's see, let's go ahead and just pick a capacitor. Now remember, before you ever test a capacitor, you're gonna wanna discharge it. For these smaller ones, you can just short them out. And then that way you're not at risk of damaging your meter. And which one did I grab? 1 nanofarad. So for that, I would select the 20 nanofarad setting. And these capacitors are not polarized. Okay, it's coming in at just under 1 nanofarad. What would be the next measurement down? Pico, what's that? 890 picofarads? And then we could just go ahead and discharge that. Now, unfortunately, we do measure, picofarads are pretty common for hobbyist electronics kits like this capacitance kit. So let's go ahead and pick this 10 picofarad capacitor and see how it measures it. Yeah, it's not even going to register it. So these really small valued capacitors, you're not going to be able to read, but you are going to be able to read these larger ones because we have millifarads available to us. Like I can pick out of this kit. This is going to be 1000 microfarad or 1 millifarad. And we can make sure that's discharged. Now, when you are testing a capacitor, we want to look to see how these ones are polarized. So we have a negative sign here for your negative lead. And then it's going to take a second to charge up the capacitor before we're going to be able to get a reading on it. So just give it a second if it's not working at first. There we go. So this is coming back and it's saying 553 microfarads. Is that a bad capacitor or is this measuring inaccurately? Let's try it with another meter to just go ahead and compare. And we'll set this up so hopefully there's no glare for you. Let's move these wires here so it's not too confusing on the screen. A couple of wires gets really crowded on this kind of a setup. Okay, we're gonna go ahead and select our capacitance setting and give it a minute. No, this is coming back as 1100 microfarads, which I believe is right within tolerance. So I do not think our ANENG multimeter is coming back very accurately with that large of a measurement. Let's try a smaller measurement. Let's give it the benefit of the doubt. I always like to cheer for the underdog. I think everybody does. Let's see. This is about 50 microfarads, so I think that's right about the middle of the road. It's 47 microfarads to be. And so if we're at 47, we can put this to the 200. So that the way that the scaling works here on your meter is it's basically saying up to, right? So up to 20 nanofarads. And then let's say you had a capacitor that was rated for like 25 nanofarads, you would go to the next setting up and so forth. Something that I like to do with the manual ranging meter though, is I like to always start at the biggest setting and then work my way down because you're not always gonna know what you're trying to measure, the value of it, right? So if it's an unknown, start big, work your way small, kind of like a microscope. You're kind of zooming in on the resolution, trying to get a clearer and clearer picture. Okay, what we say this one was rated for? 47. Okay, so this one's coming in at 50 microfarads. And then let's compare that to our Fluke really quick. I mean, there's a very large difference in price, so I would expect a large difference in accuracy. Cool, but we want to know what's going to be able to be reliably measured with this and not. And it looks like the extremes, high and very low, are not going to be very accurate measurements, but it seems like kind of down the middle of the road, you should be just fine with the results that you're getting back. So that's cool. All right, great. Let's go ahead and move along to our battery testing. Now, kind of a misnomer that I always like to point out, because these battery settings here, 12, 9, and 1.5 volt, can be kind of common on some of these lower end meters. The 12 volt battery setting on here is not to test your car battery. Testing a large cell like that is a completely different animal that requires a whole different set of test equipment and procedures and theory and all that different stuff. So the 12 volt setting here, yes, it is putting a very, very small load on a 12 volt source, but it's nothing that's going to tell you with any amount of certainty whether or not that's a good cell or not. Let's go ahead and turn on the breaker for that. Okay, very, very small load, nothing that would be required for that large of a battery. Okay, I already said that. But then we can go ahead, something like your 9 volt battery, like this, This is what it's meant for. These little guys, it's going to put a small little load on there, and then it's going to come back. Remember, this is 12 volt nominal. So a full charge versus nominal is going to be different. It's going to be more. You'll want to measure more because actually 12 volts on a 12 volt battery, I think is close to dead. Okay, and then this is our 1.5 volt, and that'll be a different load. The amount of load the amount of impedance it's putting on the battery should be in the manual, but I'm not sure. So anyways, there's your battery settings. Next, we're going to move on down to your amperage settings. So we're going to make sure to do these in series with our circuit because it is a manually selecting meter. I'm going to start big and then work my way small. And on top of that, I'm going to move this red lead into this 10A port. That stands for up to 10 amps. These are unfused ports, which means you can really mess things up. So you need to be very careful. But on the 10 amp setting, you can carry a lot more current. But something to be careful of is when your meter is in this setup, your meter is acting as a jumper wire and you can short things out, including the meter itself. So those are things that we want to be careful of when doing this type of measurement. So we're going to go ahead, get a couple different loads set up here so you can kind of see what it should look like and what to expect when you're doing this kind of measurement. I'm going to give it a 12 volt source. Then I'm going to use the meter, right, to complete the circuit. And even though it says it's rated for 10 amps, I wouldn't do anything close to 10 amps. So we can see here, we're pulling about 2 amps for this light bulb here, incandescent bulb. Then I got a little motor here, and we can see it's pulling about 430 milliamps or 0.43 amps, okay? For my next series of loads, they should all be a lot smaller, but I can leave it in this configuration for now. And you'll see what I mean here in a minute. That's why I like to do all practical demonstrations to give you an idea of what's going on. I can use these resistors as little loads and see what my load is going to be before I adjust my settings. Okay, so here I'm only pulling 110 milliamps. It's a pretty small amount of current. So what I can do now is swap this setting because I'm not doing anything more than 200 milliamps. And then this port right here is rated for up to 200 milliamps. That's what it's trying to tell you. So what we can do, I hope the meter didn't just break. I heard a snap. If it did, this video's over. It's happened to me before. Okay, let's go ahead and take a measurement and see what we have. Okay, meter's not broken yet. So now we have a much more accurate, and you can see down here too, it's saying, okay, you're measuring 124 milliamps and we're in DC. Now, if it was an AC circuit, we can move it to AC and then that'll change the reading, okay? But we're not, we're just in DC. And we can go ahead and then we can do a smaller measurement. See, this one's only about 12 milliamps. So now I can move, if I want to get more detail, more accuracy of my measurement. See, we only have one placeholder here, 0.1. So we're reading to the tenths. If I move this down, that'll allow me to read to the hundredths. Okay, so now we can see it's really 12.24 milliamps. But if I go to if I'm on this 2 milliamp setting, I see an OL. And that's going to tell me I'm out of the limits, right? So when you see an OL, it doesn't mean that nothing's going on. It just means that it's out of the limits of the setting. Let's put it back to the 20 milliamp. Let's do this last one. Okay, this last one's pretty small, 1.19 milliamps. Let's read it to the thousandths. And that should be 1,191 microamps or 1.191 milliamps. Very cool. All that is coming back within, everything's reading normal. Okay, so next we're going to have our continuity and our diode settings. It's going to be down here. Okay, that little arrow guy there is for diode, and then that little tone, that's like a little speaker tone, that's for continuity. So usually it'll default to continuity, and this one does, and we can see that annotated right there. It's letting us know. So what does that mean? Well, it means that when there's flow, when there's connection, when things are whole and everything is right in the world, it'll emit a little tone. And you can see that we have a light coming up. Something that I don't like that you'll see on these cheaper meters is that tone should always be there when we have continuity. And see how it keeps dropping out, but my leads are still touching? That'll confuse you, but that's okay. What is continuity good for? It's good for sorting out which wire goes where. See, you got this little 9-volt battery terminal. Okay, I can see that black goes to this one and not to that one. And then that must mean that red goes to that one and black doesn't go to that one. So it's good for sorting out wires, especially if you've got a whole bunch of them going on. It can be really confusing. And let's go ahead, we'll hit that select button. That'll take us to our diode setting. Can have a little bit of fun here. And diodes will always test in both directions, excuse me. Great, and we're seeing the voltage drop. That's what that number is right there. And the voltage drop for our diodes that we want to see in this direction, we want to see between 500 and 800 millivolts of voltage drop. Voltage drop is its own whole topic. That could be a whole video. I'm sure there's a bunch of really good ones out there on YouTube already, but that's what we're looking for. And then we'll test it in the other direction, and we should see that OL telling us that there's no backflow in our diode, and that means that it's testing good to go. A little extra one that I like to do is I like to see if they can light a white LED. It's like an extra little test. And this one does not look like it is able to. It cannot. So there you go. Now we have our resistance settings. So back to kind of what I've been talking about before with our resistance. We can start really big if the values are unknown, and then we can work our way down really small. So I've got these resistors here that I use as loads. I've got it set to the 200 mega ohm setting. So think of mega as millions. So this can test up to 200 million ohms of resistance. I have not come across a meter yet that has a hard time being accurate with resistive measurements. So that's reading 1 mega ohm. Man, 200 mega ohms on there. That is impressive. Okay, and then we're seeing this one is too small of a value. Won't even bring it up. So let's go to 2 mega ohm. Okay, and so now it's saying that this resistor is 0.097 mega ohm, because we got that capital M. So that would be 98,000 ohms, or probably 100K ohm resistor. We can go to the next one down. Okay, 0.009 mega ohm. How many ohms would that be? Well, it'd probably be 9,000. Let's go ahead and bring it down the wheel. 9.9K ohms. Okay, so now we're getting more accurate as we go down. If I put it on this 20K ohm setting, now we can see that it's really 9.92 kilo ohm, or 9,920 is what it's trying to say. So did you notice as we went smaller and smaller, so even though it's 9,000 here, we go down the settings, 9,900, oh, it's 9,920. So we're getting that clearer resolution as we go down, but if we go too far, then it's OL. It's out of limits. Can't read that small. It's above that 200 ohm setting there. So we can leave it back on the 20K. Go down to our next. Okay, 0.97K ohm, which would mean 970. And that's still out of the 200 ohm setting. 33K ohm, that'll still be out of that. And then this should be 100 ohm. Put it there. 100 ohm. Okay, and lastly, we have our voltage settings, which are going to be rated for both AC and DC. I would be very, very careful measuring voltage with this meter. It's very cheap. I personally would not recommend a meter like this quality for anything over really 12 volts. So I would use this for automotive or hobby electronics. I would not be trying to measure the wiring in your house or at your panel or anything like that. I know it says that it can. I wouldn't trust it personally. That being said, got this little light bulb going on here. We've got a power source, and we want to check to see how much voltage is at our power source. Now, I'm getting no measurement, but we can see it's on, okay? Why would that be? This is going to be things that trip you up when you're trying to make measurements and you're still learning. It's still set to DC. I'm measuring an AC circuit. Hit my select. Now I have my measurement. I can press hold, and it'll hold that measurement for me, and I can write that down or show it to my friend, take a picture and hang it on the fridge, whatever you like to do. But there is, so we have 200 volt setting and then a 200 volt setting. Excuse me, we have a 600 volt setting and then a 200 volt setting. So something I could do is I could bring my measurement down to the 200 volts, make sure it's on AC, and now I can read that voltage to the 10th, which is pretty nice. But if I go to the 20 volt setting and I make sure it's on AC, it's out of range. So that we can't do that anymore. We can look at a 12 volt setting. Now with DC voltage, red to red, black to black, it's going to matter. When you're measuring AC, it doesn't matter. Just for DC. Now what happens if you do? You're going to get that negative sign there, showing your polarity is reversed. Well, I hope that clears it all up. If you have any questions, comments, or concerns, please let me know down in the comment section below. Be sure to check out my link tree for discounts and different products. I'm always keeping it up to date, and maybe you could find some goodies in there. So I hope this was helpful. If it was, leave me a thumbs up. If not, give me a thumbs down. Anyways, I'll catch you on the next one, and thanks for joining me in another adventure in the garage.